We all have played with magnets at some point and have seen how one magnet attracts or repels another magnet. We have also seen that objects made of iron stick to magnets. Due to these properties of magnets, we use magnets in some form almost every day. But have you ever wondered why a magnet sticks to another magnet, or iron but not to wood or plastic? Have you ever noticed that after coming in contact with an iron object, it starts behaving like a magnet itself? In today's video, we will try to understand the answers to all these questions from a scientific perspective. Magnetite is naturally found in a magnetic state and has been used for a long time. Its mention can even be found in ancient texts. Our ancestors understood that a magnet attracts or repels another magnet. This means that a magnet has two poles. They also understood that both poles of the magnet attract iron. So, they started giving different shapes to magnets and soon discovered that if a thin needle of a magnet is suspended, it always aligns itself towards the north-south direction of the Earth. This way, the two regions of the magnet were named the North Pole and the South Pole. And thus, the invention of the compass, a device indicating direction, was made. In 1820, a scientist named Oersted was experimenting with electricity. He observed that when electricity flows through a wire, a nearby suspended compass needle starts moving. This experiment astonished scientists worldwide because it was the first experiment to establish a relationship between electricity and magnetism. After that, many scientists such as Michael Faraday, Biot, Savart, Arago, and Ampere began researching on this subject. They observed that when current is sent through two wires in the same direction, they attract each other, and when sent in the opposite direction, they repel each other. They also observed that when current flows through a wire, it attracts small pieces of iron towards it. This means that when current flows through a wire, it behaves like a magnet itself, leading to the invention of the electromagnet. Scientists also explained that every magnet has a magnetic field. When another magnet enters this field, it experiences a force called magnetic force. As the magnets move away from each other, the force decreases. Faraday introduced the concept of magnetic force lines to understand this magnetic field. He said that magnetic force lines emanate from a magnet, which he visualized by placing small pieces of iron around a magnet. These lines are imaginary but help estimate the magnetic force. Where these lines are closer, the force is stronger, such as near the poles of the magnet, and where they are far apart, the force is weaker, such as away from the magnet. Now, with Oersted's experiments and the discovery of electromagnetism, it was understood that when current flows through a wire, it behaves like a magnet. But at that time, no one knew what current actually was. What is it that travels from one place to another through wires, or what is responsible for current? This was discovered in 1897 with the discovery of electrons. It was found that every atom contains electrons, which have a negative charge and are responsible for current. Soon, the complete structure of an atom was understood, and it was found that each atom contains protons and neutrons forming a nucleus, and electrons are distributed around this nucleus in orbitals. Watch our video on atoms to understand their structure in detail. As electrons are charged particles, their motion in orbitals creates a magnetic field, just like current flowing through a wire. With this orbital motion, electrons themselves behave like magnets. It seems as if the electron is spinning on its axis like the Earth spins on its axis. This is called spin, and it creates a magnetic field. Now, the magnetic field of an atom, which has many electrons, is the sum of the magnetic fields produced by the motion of all electrons in orbitals. But you might be wondering that, if all atoms produce a magnetic field in this way, then shouldn't all substances be magnetic? But that's not the case because each orbital can accommodate a maximum of 2 electrons, and the spin of these 2 electrons is in opposite directions. So, the magnetic field produced by one electron cancels out the magnetic field produced by the other electron, resulting in a total magnetic field of 0. Therefore, if the total magnetic field produced by all electrons of an atom is 0, then it is not magnetic and is called diamagnetic, like zinc. This means that only those atoms whose some orbitals are not completely filled can be magnetic, such as iron, cobalt, or nickel. And then, how magnetic an atom is depends on how many orbitals in an atom have only one electron. Now let us understand what happens when these magnetic atoms come close to make something. When atoms come close, their magnetic fields affect each other. In such a situation, It is essential to understand how these atoms and their magnetic fields are arranged in that substance. If all magnetic atoms in a substance are arranged in such a way that all their north poles or south poles are in the same direction, then such a substance is called ferromagnetic. If they are in opposite directions, then it is called antiferromagnetic, and if they are arranged irregularly, then it is called paramagnetic. Generally, this situation also depends on the temperature. With an increase in temperature, ferromagnets start behaving like paramagnets. In antiferromagnets, even though there are magnetic atoms, the magnetic field produced by these atoms cancels out due to their arrangement, resulting in zero magnetic field. From here, we can understand that whatever magnetic object we use is essentially ferromagnetic, because all its atoms collectively produce a magnetic field. Now what happens if a magnet is broken? After breaking, the atoms of both pieces will collectively produce a magnetic field, and thus, we will have two magnets. No matter how many times we break these pieces, they will always become new magnets. This means that the north and south poles of a magnet cannot be separated. Now, you might have noticed that sometimes iron objects, although not magnetic, start behaving like magnets when they come in contact with a magnet. Why is that? In 1907, a scientist named Weiss explained that in such ferromagnets, different regions are created called domains. All atoms in a domain have their magnetic field in a specific direction. Thus, each domain behaves like a small magnet. In such substances, these domains rotate irregularly, causing the magnetic field of the entire substance to cancel out. Now, if an external magnetic field is applied, all the atom's magnets align in the direction of this strong magnetic field, and thus, the object starts behaving like a magnet. It should be noted that the use of these domains is also done in hard disks for recording information. I hope you have learned a lot about magnets from this video. If you like this video, please like and subscribe to our channel. Please also follow us on Instagram and X, where we provide more such information. Jai Hind, Jai Bharat.